The universe is so vast, and the concept of stardust has been employed as a metaphor to explain the beginnings of life. According to the theory, stardust serves as the origin of all living things, regardless of size. This proves that everyone is connected to each other and the universe. Our understanding of existence is shaped by this metaphor, which also makes us feel like we belong to the world. It also aids in our understanding of how similar we are to one another, because we are all composed of the same substance. Supernovae in stars may have led to the creation of many elements which make up our bodies, including those which were created in stars and eventually became part of our human body. Planetary scientist and expert on stardust, Dr. Ashley King explains, the components of the human body were almost all produced in stars, and many of them came from numerous supernovae. This is actually quite true. According to our calculations, the Big Bang occurred 13 or 14 billion years ago, creating the universe. Only the lightest elements such as hydrogen, helium, and trace amounts of lithium were present at the time. Matter that cannot be divided into simpler elements is called an element. Each element's atomic number, which indicates the number of protons in its atom's nuclei, stands out on the periodic table. As clumps of gas grew closer together and eventually started to burn up, the first generation of stars emerged. The core of a star will have a nuclear reaction as a result. More than 50 times bigger than our Sun, the first stars to develop following the Big Bang. Ashley explains that a process known as nucleosynthesis, which is essentially the creation of elements, occurs inside stars. The fuel is burned more quickly by larger stars. Since the early stars burned through their fuel quickly, only a few elements heavier than helium and hydrogen could be formed. When these stars went supernova and ejected the elements they had produced, the subsequent generation of stars was seeded. By examining a star's color, scientists can determine its age and surface temperature. Older and cooler stars burn red, whereas hotter stars burn blue. After that, other heavier types of elements like carbon, magnesium, and practically every element in the periodic table may be created by the following generation of seeded stars. Any element heavier than iron in your body has traveled through at least one supernova. Therefore, it is extremely possible that a large number of distinct stars contributed to the formation of the components that make up your body and our solar system. The burning that occurs inside of stars consumes a massive amount of fuel and generates a massive amount of energy. The Sun accounts for more than 99% of the mass in our solar system. These stars are enormous objects that are squeezed by gravity. Our Sun is steady because a star's internal burning produces energy that balances the pull of gravity. Until they run out of fuel, stars remain in this gravity-dependent equilibrium. Ashley explains, when that occurs to incredibly large stars, you can get some really amazing supernovas. Our own Sun won't be nearly as dramatic as that, one will say. All the elements produced inside stars are swept into space as they die and lose their mass. Then from those components, the next generation of stars forms, burns, and is propelled once more. Galactic chemical evolution is the name given to this ongoing recycling of everything, according to Ashley. Every element was made in a star, and by combining different elements, you may produce various minerals, gases, and even larger objects, like asteroids. You can begin creating planets from asteroids, and from planets, you can begin creating the elements necessary for life, such as water. At some point, you can create us. Our solar system is believed to have created only 4.5 billion years ago. However, this process has been ongoing for approximately 13 billion years. Smaller stars have a lifespan of more than 10 billion years, while large stars only endure a few million. It is difficult to watch a star form and observe the process in real time. What you see through a telescope when you observe the stars likely occurred millions of years ago, according to Ashley. Color and temperature can only tell you a portion of what their makeup looks like. Although this kind of occurrence is uncommon, a supernova in 1987 did allow scientists to observe and record a ring of material being expelled. Finding samples of cosmic dust and examining them under microscope is another method for learning about the life cycle of stars. A single particle of this extremely pure original stardust, which is 100 times smaller than the width of a human hair, and is known as a pre-solar grain since it predates our Sun, is so small that it is invisible to the human eye. We discover it in the incredibly pure prehistoric meteorites that originated on asteroids in the early solar system and were never altered, according to Ashley. It is compatible to searching through a large field of haystacks for a needle. Essentially, a scientist has to disintegrate 99.9% of a small chip of an ancient meteorite in order to obtain a small amount of silicon carbide, graphite, and nanodiamonds as byproduct. Acid-resistant materials that are created at high temperatures in stellar atmospheres are left behind. Are we really made of stardust? The answer to this question is not an easy one, because there are many different perspectives on what it means to be human. Scientists and philosophers have been debating this for centuries. Some believe that we are made of stardust because we are all made of the same thing. Others believe that there is a divine spark inside us, which makes us fundamentally different from the rest of the universe. The idea that we are made from stardust has existed for some time, but it has never been more precise than it is now with modern science and technology. Over the period of billions of years and numerous star lives, the majority of the components that make up our bodies were created in stars. However, it is also possible that part of the lithium and hydrogen in our bodies, which together make up just a small fraction of 9.5% of our total mass, came from the Big Bang. We are all made from stardust. It is a beautiful thought, and one that gives us perspective on our place in the cosmos. The atoms that make up our bodies were forged in the furnaces of stars. But it's not just the atoms that make up our bodies that are made up of stardust. It is also the atoms that make up our thoughts, feelings, and emotions. We are all part of the universe, and everything in it is connected to each other. And this should be an inspiration for us to cherish life, love one another, and take care of the world we live in. We are all made from stars, so we can be seen as part of something much greater than ourselves.